Extraterrestrial engineering councils credit humans with building infrastructure for everyone. Part 1. The meeting hall on Axis Prime Station stretched 300 meters in every direction. Thousands of beings filled the space, their forms as varied as the stars themselves. Some floated in specialized atmosphere bubbles. Others stood on legs, tentacles, or crystalline bases. A few existed as pure energy, contained in magnetic fields that hummed softly in the background. Commander of the consensus called the session to order. His crystalline body chimed like bells as he moved to the center platform. "We gather today to solve a problem that has plagued our galaxy for generations," he announced. His voice translated into 800 languages simultaneously. The Outer Rim territories remain empty, uninhabitable, deadly to all known forms of life and construction. A holographic display materialized above the crowd. It showed 17 planets and 42 moons, all marked in red: harsh radiation, unstable geology, toxic atmospheres, extreme temperatures that could melt steel or freeze nitrogen solid. The display cycled through images of failed colonies, twisted metal, and abandoned dreams. "We have tried," continued. "They brought their molecular binding technology. It failed within 3 cycles. They offered their bioadaptive structures. The radiation destroyed them in days. We, the consensus, attempted force field architecture." He paused, a gesture that suggested shame among his people. "Our proudest achievement lasted 6 months before catastrophic failure." Silence filled the hall. Every species present had lost resources, time, and sometimes lives trying to tame the Outer Rim. The territories held valuable resources and strategic positions, but the cost of development exceeded any possible return. The galaxy had essentially given up. A delegate from the collective rose, her translucent form shimmering. "Perhaps we should accept reality. Some places are simply not meant for habitation. Our efforts might be better spent elsewhere." Murmurs of agreement rippled through the crowd. Decades of failure had worn down even the most optimistic engineers. The Outer Rim would remain a wasteland, a monument to the limits of galactic achievement. Then the doors opened. The humans arrived 40 minutes late. There were 12 of them, and they looked distinctly out of place among the sleek, advanced species filling the hall. They wore simple jumpsuits with patches and insignias that meant nothing to anyone present. Some carried data tablets that appeared almost primitive compared to the neural interfaces and quantum processors other species used. One human was eating something from a wrapped package, chewing casually as she walked. The lead human, a woman with dark hair pulled back in a simple tail, approached the central platform. Her identification tag read Maria Santos, Chief Engineer. She carried a worn briefcase that looked like it had survived several small explosions. "Sorry we're late," Santos said, her voice carrying easily through the translation system. "Our ship's navigation computer had a disagreement with the station's docking protocols. We won the argument, obviously, since we're here." His crystalline form flickered with what his species considered confusion. "You are the human delegation." "That's right. You put out a call for engineers to review the Outer Rim development problem. We reviewed it during the trip here." Santos set her briefcase down and pulled out a thick stack of papers covered in handwritten notes. Several species in the crowd made sounds of disbelief. "Paper. Actual physical paper." And asked carefully, "What is your assessment?" Santos looked up at the holographic display showing all the failed colonies. She studied it for a moment, then turned back to the crowd with a slight smile. "We can have the first phase operational in 18 months. The hall erupted. Delegates from dozens of species stood, their various forms expressing shock, outrage, or amusement. The representatives' laughter sounded like wind chimes in a storm. An engineer shouted something about humans clearly not understanding the scope of the problem. Raised his appendages, calling for silence. When the noise died down, he addressed Santos directly. "You understand what you are saying. The greatest minds in the galaxy have attempted this for decades. You claim you can succeed in 18 months. Well, the first settlement anyway, Santos replied. She pulled up her own display, linking it to the central system. Her team's designs appeared above the crowd, three-dimensional blueprints that looked nothing like standard galactic engineering. We'll start with Planet 4 and Moon Base Gamma 7. Both are challenging but workable. An engineer near the front studied the designs with growing alarm. These specifications, you cannot be serious. These support structures would never pass basic safety protocols. The materials you have listed are classified as unsuitable for permanent construction, and these foundation designs. He trailed off, his form flickering with what could only be horror. You are planning to build on active fault lines. That's right, Santos said cheerfully. 4 has a magnitude 5 or higher quake every 3 days. No point fighting it. We'll build to move with them instead. Another engineer, this one from a species that resembled a floating collection of metallic spheres, spoke up. The radiation on Gamma 7 would require shielding so thick that no meaningful structure could be built. Our calculations show. We've seen your calculations, one of Santos's team members interrupted. He was a stocky man with graying hair and the weathered look of someone who had spent years in difficult environments. His name tag read, Safety Officer. You're trying to block 99.99% of the radiation. We only need to block enough to keep people alive and healthy. Big difference in shielding requirements. Enough to keep people alive is not a construction standard, said, his tone sharp. It is on Earth, replied. We've built cities on fault lines that make 4 look stable. We've got structures in deserts where summer temperatures could cook metal. We've got underwater habitats, sky-high towers in hurricane zones, and research stations in frozen wastelands. Every single one of them was built in an environment that tried to kill us. We're still here. Santos pulled up another set of images. These showed human construction projects, a massive bridge spanning a bay, built in an area known for earthquakes, a city of millions sitting on land that had been swamp and ocean, platforms drilling for oil in seas with waves that could swallow buildings, a tunnel beneath an entire ocean, a station at the bottom of the world where temperatures dropped so low that flesh would freeze in seconds. This is what humans do, Santos said quietly. We build where we're not supposed to. We build where every reasonable calculation says it's impossible, and then we live there, sometimes for generations. The representative studied the images with her multiple sensory organs. These structures, many of them appear temporary, makeshift. Some are, some aren't, Santos admitted. That bridge there has been standing for 90 years. That underwater platform has survived storms that would tear apart most space stations. The point isn't whether they look pretty by your standards. The point is they work. Was silent for a long moment. Finally, he spoke. Your methods violate virtually every engineering standard we have established over 10,000 years of galactic cooperation. Probably, Santos agreed. Our standards were developed over about 200 years of industrial construction, and before that, thousands of years of building with whatever we had on hand. We don't have the luxury of 10,000 years of refinement. We have a planet that's tried to kill us in every way imaginable, and we survived by building fast, building smart, and building to last just long enough to learn how to build better. She gestured at the outer rim display. You're trying to build perfect structures that will last forever. That's admirable. It's also why you failed. We'll build good enough structures that will last long enough, and we'll maintain them, improve them, and replace them as needed. In 18 months, you'll have working colonies. In 5 years, you'll have thriving settlements. In 10 years, you'll wonder why you thought this was impossible. The hall fell silent again. Every delegate present knew the stakes. The outer rim represented enormous potential, but also enormous risk. Accepting the human proposal meant abandoning standards that had kept galactic construction safe for. Rejecting it meant admitting defeat. A small voice came from the back of the hall. What do you need from us? Santos smiled. Give us the contracts, give us access to the sites, and then get out of our way. We've got work to do. Looked around the hall, seeing doubt and hope warring on every face present. The council will vote, he said. But first I must ask, what happens if you fail? What happens if these good enough structures collapse? If the colonies fail like all the others? Santos met his gaze steadily. Then we'll pull out whoever's left, figure out what went wrong, and try again. That's what humans do. We fail, we learn, we build again. The only real failure is not trying. The vote took 3 hours. In the end, the humans got their contract, largely because no one else had any better ideas. As the delegation prepared to leave, approached Santos one final time. I hope you understand the magnitude of what you have promised, he said. Santos hefted her battered briefcase. Commander, we once built a wall you can see from space, and we did it 2,000 years ago with nothing but human labor and simple tools. We've put people on our moon, probes on planets across our solar system, and we're working on going further, building some settlements in harsh environments, she grinned. Like I said, that's just Tuesday for us. Part 2. 6 months later, a ship carrying official observers from the Galactic Engineering Council approached 4. Stood at the observation window, his crystalline form reflecting the planet's harsh red surface. Beside him, the delegate's shimmering thought in motion pulsed with nervous energy. Behind them, a dozen other species representatives waited in various states of anxiety. I calculate an 87% probability that we will be documenting a disaster, Shimmering Thought said. Her mathematical predictions had never been wrong, and everyone knew it. Had to agree. Every report from the human base camp had sounded like a description of controlled chaos, safety violations, protocol breaches, methods that every principle of sound engineering, and yet somehow no catastrophic failures. The humans were either incredibly lucky or incredibly reckless, possibly both. The ship entered orbit, and the observers got their first clear view of the construction site. What they saw made no sense whatsoever. The surface of 4 was a nightmare of unstable geology and toxic atmosphere. The temperature swung 50 degrees between day and night. Seismic sensors showed constant low-level tremors, with major quakes every few days like clockwork. The radiation levels would kill most unshielded organics in hours. And the humans had built a town. Not a small outpost, not a temporary camp. An actual town with streets, buildings, and what appeared to be a central plaza with actual plant life growing under atmospheric domes. The structures were strange, angular, modular, connected by flexible joints that seemed to move slightly even as they watched. Nothing looked like standard galactic architecture. Everything looked jury-rigged, improvised, cobbled together from materials that shouldn't work. Request permission to land, said, not entirely sure he wanted it granted. The reply came from a human named Jackson who seemed to be in charge of the landing zone. Sure thing, Commander. Watch out for the tremor warning system. If the lights start flashing red, grab something solid. We've got a medium-sized quake scheduled for about an hour from now. Scheduled? Shimmering Thought asked. Well predicted, Jackson amended. These quakes are pretty regular. We've got the pattern down. The observers landed and stepped out into a world that should have been instantly lethal. Instead, they found themselves in a pressurized corridor connecting the landing pad to the main settlement. The walls were thick, reinforced with some kind of metallic mesh. Not elegant, but functional. Santos met them at the entrance to the main habitat. She wore a hard hat covered in stickers and what appeared to be dried mud. Welcome to New Hope Settlement, she said, clearly proud. Population currently at 200, but we've got housing ready for 500 more. Power generation is stable. Water reclamation is running at 110% efficiency, and we just got the greenhouse operational last week. Looked around in disbelief. The habitat's interior was clean and well lit, but every structural element visible showed the same improvised character as the exterior. Exposed pipes ran along ceilings. Support beams were clearly added after initial construction. Flexible joints connected rigid sections, allowing for movement. It looked like a structure that was constantly being built and rebuilt. "How is this possible?" asked. "Our surveys showed this location had a magnitude 6 quake just 3 days ago." "Magnitude 6.3, actually," said, appearing from a side corridor. He carried a tablet showing structural stress readings. "It was a good test. We had some minor cracking in Habitat 7, but the flexible connections did exactly what they were supposed to do. Absorbed the shock, distributed the stress, kept everything standing. We patched the cracks yesterday." "You had structural damage, and you consider that a success?" Shimmering Thought's form rippled with confusion. "Damage that we anticipated, planned for, and repaired quickly," corrected. "If we tried to build something rigid enough to resist the quake, it would have shattered. Instead, we built something flexible enough to survive it. There's a difference between damage and failure." Santos led them on a tour of the facility. Every new section revealed more of the human approach to engineering. In the power generation area, they found a fusion reactor that had been modified in ways that would make any engineer faint. The shielding was half as thick as it should be, but humans rotated shifts frequently and monitored radiation exposure constantly. "We keep everyone safe," Santos explained, "but we don't waste resources on shielding empty spaces." The water reclamation system used a combination of molecular filters and human reverse osmosis technology, creating a hybrid that was simpler and more efficient than either alone. The greenhouse used adapted earth plants that had been modified to handle higher radiation levels. "We started with lichen that grows in nuclear reactor cooling ponds back home," the botanist explained. "If it can handle that, it can handle this." But it was the foundation system that truly shocked the observers. Santos took them down to the maintenance level beneath the main habitat. The floor above rested on massive springs and hydraulic shock absorbers. Seismic sensors fed data to a computer system that constantly adjusted the tension, allowing the entire structure to move independently of the ground beneath it. "When a quake hits, the ground shakes, but the building sort of floats," Santos explained. "We borrowed the concept from earthquake engineering back on Earth. Some of our tallest buildings use similar systems. The trick is letting the structure move with the force instead of resisting it." Examined the supports with growing concern and admiration. I cannot say this is safe by any standard I know, but I also cannot deny that it appears to be working." "It's safe by human standards," said, "and we've been building in earthquake zones for centuries. Tokyo, San Francisco, Istanbul, all built on major fault lines, all still standing after hundreds of major quakes." The tour continued to Moon Base Gamma 7, accessed by a shuttle that made Shimmering Thought calculate a 23% chance of hull breach during transit. The shuttle survived, much to her surprise. Gamma 7 presented different challenges than 4. The radiation here was the main killer, intense, constant, and deadly. The moon had no atmosphere, no magnetic field, nothing to stop the cosmic rays and solar radiation from battering the surface. The human solution was characteristically insane. They had built the base underground, using the moon's own mass as shielding. But instead of digging deep, expensive tunnels, they had found natural lava tubes and expanded them using controlled explosives. The result was a massive cavern network that provided natural shielding at a fraction of the cost. "We call it speed tunneling," the site supervisor, a woman named, explained. She had the same weathered look as the appearance of someone who had worked in difficult places. "We map the existing geological structures, identify weak points, and use precisely calculated charges to expand them. It's faster than drilling and uses the environment's own features instead of fighting them." "Controlled explosives," repeated slowly. You are using explosive charges to create habitable spaces in one of the most unstable environments in the Outer Rim. Yep, said cheerfully. We did the same thing building train tunnels through mountains on Earth. Sometimes you've got to blow things up to build them properly. The base itself was a marvel of efficient design. Every space served multiple purposes. Storage areas doubled as radiation shelters during solar storms. The main corridor was wide enough to move equipment but also served as a gathering space. Even the waste processing system generated usable heat for the living quarters. But it was the maintenance schedule that really revealed the human philosophy. Every structure had a detailed log of repairs, modifications, and updates. Nothing was considered permanent. Everything was designed to be fixed, improved, or replaced as needed. Our buildings aren't immortal, Santos explained when asked about this. They're living systems that need constant attention. We check them, maintain them, and fix problems before they become catastrophic. It's more work in some ways, but it means we can build faster and adapt to problems we didn't anticipate. The final stop on the tour was a construction site for the next settlement. Here, the observers witnessed human methods in action. Automated drones worked in swarms, coordinating without obvious central control. Human workers moved between them, making adjustments and solving problems in real time. The construction was fast, almost frantic, but not chaotic. Every worker knew their job, and everyone seemed to be doing three things at once. A minor emergency erupted while they watched. A support beam cracked under stress and alarms started blaring. The observers braced for disaster. Instead, a construction crew swarmed the problem. Within minutes, they had the beam reinforced with temporary supports. Within an hour, they had manufactured a replacement using on-site materials. Within 3 hours, the original beam was removed and replaced, and construction continued as if nothing had happened. That, said, pointing at the repair, is why we'll succeed where you failed. We don't expect perfection. We expect problems and we're ready for them. Every worker here is trained for emergency repairs. Every structure has backup systems. Every plan has contingencies. As the day ended and the observers prepared to return to their ship, found himself struggling with contradictory thoughts. Everything he had seen violated every principle he had learned. The humans cut corners, took risks, and built structures that should fail. And yet they worked. The settlements were operational, the colonists were safe, and the impossible was becoming routine. Shimmering thought pulsed beside him as they boarded the shuttle. I must recalculate my models, she admitted. The humans have introduced variables I did not consider. What variables? Asked. Adaptability, resilience, the willingness to accept temporary failure as part of long-term success. Her form shimmered with what might have been respect. We have spent perfecting our methods. They have spent centuries improvising, and somehow their improvisation works. As the ship left orbit, composed his report to the council. He chose his words carefully, knowing that what he wrote would shape galactic construction standards for generations. Finally, he settled on a simple statement. The humans are succeeding because they have learned to work with chaos rather than against it. This may be the most important engineering lesson our civilization has ever received. Below them, on the hostile surface of 4, the lights of New Hope settlement glowed steady and bright. Humans were building the impossible, one improvised solution at a time. Part 3. 2 years after the first settlement opened, the Galactic Engineering Council convened again on Axis Prime. The meeting hall was packed even fuller than before. This time, everyone wanted to hear what would be said. Stood at the central platform, but he was not leading this session. That honor went to a human. Maria Santos approached the platform wearing the same battered jumpsuit, though someone had clearly made her clean it. Her briefcase was still dented and... Thank you for inviting me to speak, Santos began. I know many of you have questions about the Outer Rim projects. I'm here to answer them and to make a proposal that will change how this galaxy builds. The display activated, showing the current state of the outer rim territories. The red markers indicating uninhabitable zones were now mixed with green. 17 settlements across 12 different worlds and moons. Combined population approaching 200,000 with multiple species represented. Infrastructure that was not only functional but thriving. The delegate, shimmering thought, stood immediately. We have studied your settlements extensively. Our analysis shows structural stress patterns that should lead to failure within 5 years. Yet your projections claim century-long viability. This is contradictory. Santos smiled. You're looking at static models. Our structures aren't static. They're dynamic, maintained systems. Yes, if we built them and walked away, they'd fail. But we don't walk away. Every settlement has a maintenance crew, replacement parts, and regular upgrade schedules. That bridge you're worried about, we'll rebuild sections of it 3 times over 50 years. But the bridge itself will last for centuries because we never stop maintaining it. She pulled up images from Earth. Ancient stone bridges still carrying traffic after 2,000 years. Wooden temples rebuilt every generation but maintaining their essential form for a millennium. Modern skyscrapers constantly updated with new technology while their bones remained strong. This is how humans build, Santos continued. We don't create perfect, unchanging monuments. We create living structures that evolve with their needs and their environment. An engineer spoke up, his 4 arms gesturing in agitation. But this requires constant resource investment, constant labor, constant risk. Surely it would be better to build correctly the first time. Would it? Asked, standing beside Santos. Your correct methods left the outer rim empty for decades. Your perfect solutions cost so much that no one could afford them. Our imperfect solutions have people living and working in places you said were impossible, and we did it for 1/10 of your estimated cost. 1/10? This translator struggled with his tone of disbelief. Less, actually, Santos said. We use local materials wherever possible. We manufacture on site instead of shipping everything. We adapt designs to local conditions instead of terraforming the environment to match our designs. And we use a lot of human labor, which is something our species has in abundance. The next question came from a species that resembled a floating collection of crystals, the Dominion's representative. We have heard reports of casualty rates in your construction crews. 3 deaths in 2 years, multiple injuries requiring medical intervention. This is unacceptable. The room went quiet. This was the accusation that could shut down everything. 3 deaths in 2 years was indeed a tragedy, and the had clearly saved this point to make maximum impact. Santos's expression hardened. Every person who died is a loss we feel deeply. Their names were Sarah and died in a pressure seal failure we didn't anticipate, was caught in a rock slide during tunnel expansion, had a heart attack during a rescue operation in high radiation area. She paused, letting the names sink in. We have memorials for them in every settlement. We've updated our protocols based on what we learned from each death. And we've told every new worker exactly what happened and what risks they're taking. She pulled up more statistics. In those same 2 years, across all 17 settlements, we've had 0 deaths from structural collapse, 0 deaths from power system failure, 0 deaths from life support malfunction. The galaxy's standards would have prevented us from building at all, which means the 200,000 people now living and working in the outer rim wouldn't be there. Tell me which is more acceptable. 3 deaths from accidents during construction, or 200,000 people not having homes because we were too afraid to try. Stepped forward. Every worker knows the risks before they sign up. We don't hide the dangers. We train extensively, we have safety protocols, and we have emergency response teams. But we also understand that building in extreme environments means accepting some level of risk. The alternative is not building at all. The representative started to reply but raised an appendage for silence. The human methods are dangerous. This is factual, but they are also effective. Also factual. The question before us is not whether to condemn human engineering, but whether to learn from it. Santos nodded her thanks to, which brings me to my proposal. The outer rim is just the beginning. There are thousands of worlds and moons throughout the galaxy that are considered marginal, difficult, or impossible to develop. With human methods, most of them become feasible, but there aren't enough humans to build everything. She pulled up a new display. The Human Engineering Institute, jointly operated by Earth and the Galactic Council, a training program that would teach our methods to any species willing to learn, not just the techniques, but the philosophy, how to assess acceptable risk, how to build for adaptation instead of perfection, how to maintain living structures instead of static monuments. The response was immediate and divided. Half the representatives erupted in approval, already seeing the potential. The other half shouted objections, horrified at the thought of abandoning of established standards. Shimmering Thought's voice cut through the chaos. I have completed my analysis. Human methods reduce initial construction costs by 73% on average. They increase maintenance requirements by 340%. They reduce construction time by 64%. They increase flexibility in design modifications by over 800%. Overall efficiency, measured by cost per unit of habitable space over a 50-year period, is 43% better than current galactic standards. The hall fell silent. Shimmering Thought's calculations were legendary for their accuracy. If she said human methods were more efficient, they were more efficient. However, she continued, this efficiency comes with requirements, constant maintenance, trained workforce, cultural acceptance of imperfection. Not all species can adapt to this approach. Which is why we're offering to teach it, Santos said. Any species, any individual who wants to learn, will share everything, the successes and the failures, the methods and the philosophy. We'll create a new standard not to replace the old ones but to complement them. Give builders choices. The debate continued for hours. The conservative factions argued for maintaining established standards. The progressive groups pushed for immediate adoption of human methods. Compromise proposals flew back and forth. Finally, a vote was called. The measure passed with 67% approval. The Human Engineering Institute would be established, with funding from the Galactic Council and oversight from a mixed-species board. Human methods would become an optional standard, available to any project that chose to use them. As the session ended, representatives from dozens of species surrounded Santos and her team. Some wanted to sign up for the training program immediately. Others had specific projects in mind. A few just wanted to argue more about safety protocols. Approached Santos as the crowd finally thinned. You have changed the galaxy today, he said. I am not certain whether to congratulate you or warn you of the chaos you have unleashed. Santos laughed. Probably both, but that's how progress works, isn't it? Someone does something impossible, everyone argues about whether it's a good idea, and then eventually it becomes normal. There is wisdom in that, admitted. Although I suspect normal is a word humans apply differently than the rest of us. 3 years later, the changes were undeniable. The Human Engineering Institute graduated its first class of 3,000 students from 127 species. Mixed-species construction crews worked on projects across the galaxy. The outer rim had grown to 47 settlements with over 1 million residents. More importantly, the philosophy had spread. Other species began experimenting with their own versions of adaptive engineering. The developed force fields that could flex and adjust instead of maintaining rigid barriers. The created molecular bonds that could self-repair minor damage. The designed bioadaptive structures that could modify themselves based on environmental changes. Everyone was learning from everyone else, and the galaxy was better for it. Santos stood in the main plaza of New Hope Settlement, watching children from a dozen species play together under the atmospheric dome. The plants in the greenhouse had spread, creating actual gardens. The buildings that had seemed so temporary and improvised 5 years ago now looked established, lived in, permanent in their own way. Joined her, carrying 2 cups of coffee from the settlement's cafe, remembering when this was just red dirt and hope. Every day, Santos said, accepting the coffee. Some of the original crew are calling this home now. Not just a posting, but home. That's how you know a settlement succeeded. Got a message from Earth today, said. They want us back for the Institute's expansion. Need experienced instructors for the advanced courses. Santos considered this. What do you think? I think we built something impossible here. I think we proved humans can work with aliens to do amazing things. And I think the next generation needs to learn how to do it even better. He gestured at the settlement around them. But I'll miss this place. We'll be back, Santos said confidently. This is home now. We just have to go teach others how to build their own. Across the galaxy, on stations and planets, in cities and settlements, the change was visible. Construction projects that would have taken decades were completed in years. Worlds that would have remained empty were filling with life. Species that had never worked together were learning to build side by side. And everywhere, when someone said something was impossible, someone else replied with the phrase that had become famous. Have you asked a human? Because humans had taught the galaxy a simple lesson that changed everything. Perfect wasn't the enemy of good. Impossible wasn't the same as difficult. And sometimes the best way to build a bridge was to start with whatever materials you had and figure out the rest as you went. 5 years after that first controversial meeting, stood in his office on Axis Prime looking at a photo on his wall. It showed a human construction crew standing in front of New Hope Settlement, muddy and exhausted and grinning like fools. Santos stood in the center, holding a sign that read, Day 1, Watch Us Work. He had kept it as a reminder that sometimes the impossible just needed someone willing to try. Someone willing to build imperfect structures that could become perfect through care and time. Someone willing to look at a wasteland and see a neighborhood waiting to happen. The humans had taught the galaxy how to dream big and build fast. In return, the galaxy had taught humans how to build better. And together, they were building a future that none of them could have achieved alone. His communicator chimed. Another impossible project. Another world that conventional wisdom said couldn't be developed. He looked at the photo one more time, then opened the communication channel. Yes, I know it seems impossible, he said. Have you considered consulting with the Human Engineering Institute? I believe they will tell you something humans say often. This just looks like Tuesday to them. And somewhere in the galaxy, on a world that maps still marked as uninhabitable, construction crews were already breaking ground on what would become the next impossible settlement. Because that's what they did now. They built bridges in places bridges couldn't exist, homes in places nothing could live, and futures in places that had none. The galaxy had learned to build the human way, fast, adaptable, imperfect, and absolutely unstoppable.